Alright, so in the last video, at the very last example, I kind of actually did the wrong example. I did one on page 71 instead of page 70. So I'll just quickly do this one when it came to it. So ironically, it's the same alpha when it came to 0.10, but it was 19 for n, so it's going to be degrees of freedom of 18. Alright, so if we just quickly do that one, so 0.10 is here, degrees of freedom of 19. No, sorry, 18 of 18 gives you 25.989. So sorry about the confusion. Hopefully you guys went just back-to-back videos so you can see that portion. Just quickly finish out, the last example I skipped around and I actually did page this one on page 71, but it's supposed to be here. So this is the correct one for this example here. Okay. All right. So now that we know how to find the chi-squared value, right? Very simple, just like a t-value, not too bad. Is now what we're going to do is construct the actual confidence interval. Okay. Now, unlike the other ones where it's plus or minus your margin of error, this one's a little different. Okay. There is no margin of error at all. It's all incorporated into one single equation on the left and also on the right. So let's just break this down. So it's n minus 1, so sample size minus 1, times s squared, so s will be given to you in the question, right? Same as sample size is s squared, over, now this is pretty interesting, right? It says chi-squared subscript alpha over 2. On the other side, it's almost identical, except again, this is a little different. This says chi-squared value of alpha of subscript 1 minus alpha over 2. And I give you guys the definitions of what this represents here. It says where alpha squared subscript alpha, chi-squared of alpha over 2 is the chi-squared value with alpha divided by 2 area on the right-hand side. Okay, and then this portion, chi-squared of 1 minus that, is the chi-squared value of 1 minus alpha over 2 on the right-hand side as well. So essentially what's actually happening here is we're going to need two chi-squared values. And if it's easier, you kind of want the left and rightmost values. We're going to consider this as right and this considered as left, because over here, given this area, this is going to be alpha over 2. This is the chi-squared on the right-hand side. And over here, this represents all of this area over here is going to be the 1 minus the alpha over 2 portion here. This is considered the leftmost chi-squared value, hence why it's on the right and on the left. So if you guys were wondering, if you guys went back, why this, these are pretty big numbers and these are really small numbers, that's the reason why. Because when we subtract it from alpha, you get really big numbers. So these consider the leftmost areas, and these are considered the rightmost corresponding to the left and right chi-squareds. Okay. So the whole thing is we're going to do the exact same thing we just did above, but two partial twists. First, we have to divide this by 2, and then we do that special minus 1 as well. Okay. So let's try the first example out here. Okay. So actually, let's do it here. So you guys have space on the other one. Let me just put it here for you guys. Okay. So let's suppose we want to now find the two chi-squared values, right, when it came to it. When n is 30, and we have a 95% confidence interval. So remember, to find alpha, it's 1 minus the confidence interval we given to us. So alpha is 1 minus 0.95 or 0.05. And then degrees of freedom is going to be 29, right? Now remember, we want to find both chi-squared values, in other words, the right and leftmost one. So if I just break them off, I'm looking for this value and also now that value. So if I shade in what I'm given, this is now going to be not just alpha, but I have to cut it in half. So if I cut this in half, well, that gives me alpha over 2 is now 0.025. So that is what I'm going to put here as the shaded region. Okay. All right. So now that's when we correspond to that. So if now using this alpha, only this one. So if you really want, you can just cross this up because we're never going to use that anymore. It just a step to get to what we really want is this one here. So now using this one being alpha and this degree of freedom, what's going to be our chi-squared value? So 0.025 is over here. Degree of freedom of 29. gives us all the way down here, and it should be 45.722 as the chi-squared value. Okay. And there we go. Now we only found the rightmost one. That's the alpha over 2. Now we can find the leftmost one. To find this chi-squared value, what we have to do is we'll do 1 minus that number. So now what is 1 minus 0.025? And you should get 0.975 as your answer. So now this alpha and this degree of freedom, now we find the leftmost one. So that's how we found the left. That's where my 1 minus the alpha over 2 portion. So now if we go back, we have 0.97 now. So notice it's on the left-hand side, not on this side anymore. So it's 0.97. And you go back down to 29 degrees of freedom. So this time it's going to be 16.047. That's going to be the second chi-squared value. So that's how we find the left and right chi-squareds when it comes to our confidence intervals. Okay. Now the good news is if you forget, the very bottom of this, it tells you what you actually have to do, believe it or not. See, this is what we did first, and this is what we're doing now. Dividing it by 2, this is the rightmost, the leftmost, you have to subtract it from 1. Okay, so it tells you how to do it on the actual sheet. You just got to be aware of where it's actually at. Okay, so let's try another one. Okay. Let me get another piece of paper. Sorry, I wrote on this one accidentally. So this is technically supposed to be the other one here. Okay, so we want to find, again, the two chi-squared values when 90% confidence interval and n is equal to 5. Okay. So let's actually do this one now. Okay. All right. So first, we have to find alpha, which is going to be 0.10, right? Because 1 minus 0.9 is 10. And now again, right, we have to degrees of freedom is going to be 4. So this is the one I actually did earlier in the last video. Okay, so now first thing we have to do is cut this in half. So alpha over 2 is going to be 0.05. So again, just for my sake, I'm just going to cross this out because I'm never going to use that anymore. I'm only using this one. So now my alpha is over here at 0.05. And now using that degree of freedom and that alpha, what is our rightmost chi-squared value going to be? And hopefully you say 9.488. Okay. Right. And now to find the leftmost chi-squared value, you have to do 1 minus that value. So 1 minus this value gives you 0.95. So now, using this new alpha and the same degree of freedom, what's going to be our chi-squared value here? Okay. And hopefully you guys see as 0.711 as your answer. Right? So that is how we find both chi-squared values when it comes to it. So we have to find 2 of them when it comes to this type of new way of finding confidence intervals. Okay? So what do we do now is why don't we try an example so you can see how this is actually going to be formatted itself, right? So you can see what is actually going to be done illustrating this concept. Okay? So my example got a little cut off, so I'll just read it and just flip the page. So example 1 says 22 people were exposed to lead and then took an IQ test. So 22, so n is 22. The IQ score had a standard deviation of 14.3. Construct a 95% confidence interval to estimate sigma, the standard deviation of the population IQ scores. So remember, they tell us exactly what we want to do in this question, right? We want to find the standard deviation, estimate the standard deviation itself. Okay? So to do so, right, we got to find 2 special things. So we're going back up. This is our equation here. We need to figure out, right? This is our equation for confidence intervals there. So we actually need 4 numbers. N, S, this chi-squared, and then that's chi-squared. So we're just going to write down what we give into it, right? So N in this case is 22. S is our sample standard deviation. That's 14.3. Okay. And now we got to find both our chi-squared values. So again, just for that, I'm just going to write this, draw this little curve for myself to illustrate what we actually need. So first off, degrees of freedom is going to be 21, right? Just, laying that out. Second thing is, what is our alpha? So alpha is 1 minus 0.95, so that's going to be 0.05. But, right, that's just a step to what I really want is alpha over 2. So if I cut this in half, therefore, what I'm really looking for is 0.025. And just, again, for my sake, I'm just going to cross this out because I'm never going to use that anymore. All right, so now we're going to find both the chi-squared values we're looking for, right, using alpha and the degrees of freedom. So now alpha being 0.025 and degrees of freedom of 21, if we go to our chart, what is our first chi-squared value? And hopefully you guys see 35.479. Okay. So once we have that value, now we find the leftmost one. So remember the leftmost one, we have to do 1 minus this value. So 1 minus 0.025 should give you 0.975. Right? So now using this alpha, same degrees of freedom, what is going to be the leftmost chi-squared? And hopefully you guys see 10.283. Now, believe it or not, that's pretty much the work of the question. This is the bulk of the question itself. Because at this point, now we're just going to slowly put it in the calculator to slowly break it down. Okay? So to put this in the calculator, how this is going to be, it's going to be the square root of n minus 1, so 22 minus 1, times 14.3 squared, all divided by, now this is what we got to be very careful of. Now go back to the equation, right? You consider this as right and left. So we're going to do the right one here and the left one on the other side. So they actually swap places. So the right one is 35.479. And on the other side, it's identically the same thing, but we use the other chi-squared value instead. This is going to be 10.283. And then at this point, we just slowly use a calculator to help ourselves out, right? So remember, order operations, the square root comes at the very end. So, 22 minus 1 is 21. So 21 times 14.3 squared. And then divide that by 35.497. And then finally taking the square root of that number, hopefully you get 11.002. Okay. And now we do the same thing on the opposite end. So 21 times 14.3 squared. And now we divide it, but this time by 10.283. And then finally taking the square root of that should give you 20.436. And there is your confidence interval itself right there. Okay. Now remember, right, when it came to a confidence interval, we also have to interpret our proportion. So it isn't enough just to answer the question, you also have to interpret it. Okay. So I'm in a space here, so I'm just going to write it over here. So if you want to write, so unlike when you're finding E, so basically, unlike the last ones where you're finding E is your first step, writing the confidence interval is your second step, and interpreting is your third step, E in this case is finding these two values. Step 2 is still finding this, and step 3 is still interpreting. So how to interpret this question is, if you guys remember, we are, in this case, 95% confident that the population standard deviation of, now we would interpret back to the question, right? What are we actually talking about? The IQ score. So standard deviation of IQ scores is between, and now we write our numbers, 11.002 and 20.436. And that finishes the problem here. Okay. All right, so why don't you guys try the next two questions, question 1 and 2, and then on the next video, we'll put the answers together.